201. Okay, so hi everyone, thank you and welcome for joining today's vendor session brought to you by our Digital by Default sponsor, Teradici. So for today's session, I'd like to introduce you to Jack Liu and Dean Francis. Jack Liu is a solutions architect at Teradici, and Dean Francis is the manager of professional services at Teradici. Today's session will be about PCoIP Ultra, the most advanced remoting protocol for virtual workstations. And during today's session, Jack and Dean will be explaining what PCoIP Ultra is and how it supports on-premise, hybrid, and leading public cloud environments. So with that, I will hand it over to you, Jack and Dean.
Thank you so much, Madison. I will start sharing my screen. Okay, is everybody able to see?
Yeah.
Okay, excellent. Yeah. Good morning, good afternoon, folks. My name is Jack. I am a solutions architect at Teradici. And here today we have Dean. Dean, would you like to introduce yourself?
You bet. This is Dean Francis, lead our professional services team at Teradici, and we'll get a chance to talk a little bit more toward the end of the session about what we're doing at Teradici.
Yeah, for sure. Yeah. So today the topic we're discussing is PCoIP Ultra, the most advanced remoting protocol for remote workstations. Before we begin, I would like to talk a little bit about Teradici and who we are. So going to the next slide here. Teradici is a company that was founded in 2004, and we started in the hardware space, focused on remoting physical workstations using a PCIe add-in card known as a remote workstation card. And what it does is that it can encode local displays on the workstations into remote displays using our proprietary display protocol called PCoIP. And some of the first partners of Teradici are OEM manufacturers of workstations, such as IBM, HP, and Dell. On the other end of PCoIP, we have a hardware client known as a zero client that can decode PCoIP, and it's very similar in concept to a thin client. In 2009, we were approached by VMware to turn our hardware solution into a software solution for a VDI product that VMware was developing. That product is now known as VMware Horizon. Thus, it led Teradici down the path of developing a performant VDI remoting protocol that runs great in both hardware and software. In 2014, Amazon approached us as they were developing a desktop as a service solution on AWS and needed, again, a highly performant remoting protocol. Thus, we worked very closely with AWS in development of their DaaS service, which is known as Amazon Workspaces. Now, with some public cloud expertise in hand, we partner with Microsoft Azure in providing their users with an option to connect to their virtual workstations, again, with a highly performant protocol, PCoIP. And skipping forward a little bit, in 2019, Teradici has now multiple different partnerships with various different ISVs, OEMs, and MSP partners, including Tehima, in order to bring PCoIP to as many customers and different use cases as possible. So before we start talking about the technical details of PCoIP, I just want to talk briefly about the trends that we're seeing in the workstation remoting or VDI space. Number one, multi-cloud. More and more customers are moving away from being on a single cloud, and we include being only on-prem or being on a private cloud as being on a single cloud. We're seeing demand from customers to be able to support a hybrid cloud environment where the customer can burst into a public cloud as needed, or have a permanent presence in that public cloud without decommissioning their existing private cloud or on-prem infrastructure. Number two, security. As COVID-19 is impacting many different countries around the world, in order to enable their users to work from home, certain industries, such as the media entertainment industry, allow their users to bring their workstations home. This was probably the fastest way to get their users up and working, but in terms of security and IP protection, this creates an enormous security risk, as now the workstation is outside of the strong corporate borders where within the corporate borders, there may be very strong informational security, but in a user's unprotected home, things like VFX or movie shots for the next Marvel film might be accidentally or deliberately leaked. Number 3, mobile workforces. Even before COVID hit, Teradici was seeing a trend of needing to onboard remote contractors as local talent pools for certain industries, again, for the M&E industry, media entertainment, have been exhausted in cities like Los Angeles and Vancouver. So in order to remain competitive, organizations need to globalize their workforce without compromising on the quality of user experience for their users around the world. With the uncertainty of when COVID will end and life returning to normal, if we ever return to normal, your local workforce might become fully remote as employees move away from their physical offices in urban centers and back to their home state or home province or even home country. Number 4, desktop as a service. The last trend that Teradici is seeing is the move away from a purely traditional on-prem VDI solution to something that is more akin to a desktop as a service, which is what the HEMA offers, or better known as a DaaS solution, DAAS. As some organizations don't want to do the lift and shift of their on-prem VDI systems to a public cloud, as it does not result in much savings when doing a simple lift and shift, and it is just as complex to manage as their on-prem systems, on-prem VDI systems. Of course, they can re-architect their VDI infrastructures to be fully cloud native, but it requires significant technical expertise, and the expertise does not come cheap. So after talking about all of these different trends, I think what HEMA is offering is able to address almost all of these pain points. And I would invite you to take a look at some of the other sessions during the Digital by Default Summit in order to learn more about the proposition of the HEMA and the partnerships that they've been working on. Okay, so getting down a little bit into the brass tacks, the first question I'm sure a lot of you guys have is, what is PCoIP? So as stated previously, PCoIP is a display remoting protocol. So you can think of it as something that is similar to Microsoft RDP, Citrix HTX, even a VMware Blast. And what we do is we capture remote pixels on the virtual or physical machine, and then we use our proprietary algorithms and encode it, encrypt it, and then send it across the network. Could be over internet, could be a local area network, and then to a client device. So a zero client, as I've talked about before, or even a, as I'm connected right now, a Windows client. That is just my home PC, and I have the PCoIP software client installed, and it decodes the PCoIP, encrypted PCoIP protocol, and then converts it back into display. And in a fully lossless manner, actually, as we talk about the first point, the build to lossless capabilities of PCoIP. Fidelity of color, text, and line is very critical for certain industries, such as media entertainment, or in the AEC, the CAD space, even things like oil and gas, where if this color was slightly off, means the difference between missing an oil deposit and seeing that oil deposit. So for those use cases that is highly graphically intensive and the users have the highest demand for color accuracy and reproduction, PCoIP is fantastic for those protocols, for that use case. Again, second thing I already addressed a little bit, color accuracy, right? We talked about, I mentioned the media entertainment industry a couple of times. So in Vancouver, which is a very big media entertainment hub, we have a lot of different VFX studios, movie studios working out of Vancouver. And as COVID hit, they needed to enable their users, as I've mentioned before, right? Some of them just sent them home with workstations. Other studios, they saw that being an issue with their clients. So what they have done is they have installed the PCoIP software on their workstations in the office. So, the workstations are all running in the office, but there's nobody sitting in front of them because all of their users at home connecting to it remotely. And we provide the sort of the top tier experience. So when the VFX artists or the producers are reviewing the shots they've done, they can be confident that what they're seeing is what their end users will be seeing once they watch the movie at home or in the theater. Number 3, the highest fidelity. So PCoIP is a adaptive protocol. What that means is that it can sort of adapt itself and tune the things like bandwidth usage, things like frame rate or resolution, depending on how much, depending on network conditions. So if they see that the network is congested, it's able to sort of intelligently and be intelligently back off on the bandwidth usage so that it can leave some bandwidth for the other application that is on the network. Or you can also, there are options in the software to say, hey, I want you to be, to use more bandwidth, even though there may be some underlying congestion, so that users may have a better experience at the cost of higher bandwidth usage. It's a efficient multi-codec protocol. So one of the things we talk about here is AVX2, and as the title of this webinar, we're talking about PCoIP Ultra. That's where that will come in. So I'll address that in a later slide. Endpoint security. So with the zero client device, how it's differentiated from something like a thin client is that we are not running an operating system on a zero client, but rather what we have is firmware. So, when the user plugs in the power, network, mouse, keyboard, and monitor to the zero client and turn it on, you get a very simple dialog box that says, what's the IP address or fully qualified domain name you want to connect to. And that's all the zero client does, is it connects to a PCoIP host, and that's it. And the zero client being fully dedicated silicon, having fully dedicated silicon, is capable of processing PCoIP traffic very quickly. The last point we have here is about Wacom device. So again, Teradici being very popular in the media entertainment industry. A Wacom tablet is, I'm not sure if you have previous familiarity. What it is, you can think of it as just like a little gray slab, or it could be like an iPad type device where it has display built in. And the users take their Wacom pen, which is similar to an Apple Pencil, and they can start drawing on the tablet. And the pixels and the lines you've drawn will be reproduced perfectly on the screen that they're seeing. And we see that a lot for media entertainment in the local workstation space. But once, if your workstation is, 1,000 kilometers away, then you will start to see some latency without this device acceleration that we've implemented. So we have done we have implemented some logic within the Teradici, both the zero and the software clients, to make that experience better when the user is connecting to their workstation that may be thousands of miles or kilometers away. Okay, cool. So these are some of the features. These features, some of them apply to the original version of PCoIP, which we call PCoIP Gen 1. And some of them applied whatever applies to the original also applies to PCoIP Ultra. But certain things like the multi-codec, the multi-threaded AVX2 acceleration, that only applies to PCoIP Ultra, which I'm going to touch on in the next slide here, right? So with Gen 1 PCoIP, I would say that it's probably one of the most performant protocols today. But when we take a look at what's coming down the pipeline, we realize that there are certain workloads that we would not be able to address with PCoIP Generation 1, right? So things like 4K UHD workloads, right? Again, going back to the media entertainment industry where they need higher resolution monitors continuously because the resolution monitors for TVs at home is going to 4K, so they need to master the content in 4K, right? For certain things like high frame rates. So most movies today is shot in 24 frames per second, but we're seeing some directors or producers experiment with 60 frames per second. And if any of you guys are in the or have familiarity with gaming, even now 60 frames per second for gamers is not enough. Users are going to 120, 144 frames per second. So if you're developing a game, you need to have those high frame rate to know how the end user experience will be like. So having high frame rate support is also something that is very important to Teradici. And finally, being able to support workloads that's HDR in nature. So as if you looked at a TV recently, a lot of these TVs now today supports HDR10 or Dolby Vision. And then again, when the artist is mastering the content, they need to have it in HDR as well. And that's just not something that's not possible in the Gen 1 version of PCoIP, which is why we had to create PCoIP Ultra, right? And PCoIP Ultra is available on the Tahima platform today for endpoints for their hosts that is using cloud access software. So as you can see on the left here, right, when we talked about our partnerships in the past, we had a partnership with VMware, we had a partnership just by ourselves putting it in the public cloud, and now finally we have PCoIP Ultra. When we did that partnership with VMware in 2009, we had the SSE2 optimized version of PCoIP in VMware Horizon. And again, that's on the bottom left there. And that's sort of capable of doing 1080p 30 frames per second. And for those of you who may not know, SSE stands for Streaming SIMD extension, which is an instruction set or feature that is available in most x86 or Intel or AMD type CPUs today. When Teradici created cloud access software, we've made some additional optimizations by moving to SSE 4.2. And that enabled us to get to 1080p 60 frames per second. And again, as we looked into the looking glass, we saw a couple of trends that were coming down the pike, right? Things like 4K workloads, needing a high frame use case, i.e. 60 frames or higher, and HDR. PCoIP Gen 1 was designed in 2004 and had limitations in being capable of those future-facing features that we may need soon. And that's one of the biggest reasons why we created PCoIP Ultra. PCoIP Ultra is a new version of PCoIP that enables the possibility of adding those future features that I've mentioned previously. And it uses AVX2, which stands for Advanced Vector Extension. And this is a relatively new x86 instruction set or x86 feature. And it gives us the ability to scale out much better than what SSE is capable of, and which I'll show in the next slide. But moving to PCoIP Ultra also gave us the ability to extend beyond what we've developed in-house, but also able to integrate third-party codecs that may be complementary to what we offer. So here we see the evolution of PCoIP in terms of scaling, right? In the SSE2 version of PCoIP, in the left there, it's single-threaded and it saturates one core. In a virtualized or a cloud environment, individual core performance tends to be low, but the number of cores tend to be more plentiful. So being single-threaded in that case was definitely not advantageous. With the SSE 4.2 version of PCoIP in the middle there, we were able to become more multi-threaded and improve the performance over the SSE2 version, but we're still seeing some limitations in terms of real-world performance. And finally, with the AVX2 version and PCoIP Ultra on the right there, we are finally capable of doing true thread scaling and scale efficiently across many different cores and able to achieve a very high performance. Cool. So in this diagram, you can see how we've built multiple different codecs, PCoIP Gen 1, PCoIP Ultra into cloud access software. But notice we also included third-party codec support. And what we call out there is NVIDIA's NVENC technology. So what NVENC is a dedicated hardware that is built into NVIDIA GPUs, enabling in both consumer and enterprise-grade GPUs. And that enables hardware accelerated H.264, so H.264 or H.265, which is a video codec I'll touch upon in a bit later. And then enables hardware accelerated H.264 video encoding there. By having three protocols, three codecs built in, the IT administrator is able to dictate the preferred codec based on a GPO setting or a config file line. So we leave the option up to the organization to determine which codec fits best for their use case. So a quick note on why being truly multi-core matters. This is a diagram that shows the AVX2 engine processing pixels. The AVX2 instruction set on modern servers, workstations, and clients allows us to gather and process many pixels in parallel without loading the CPU too much, right? So here we have an example of a 16-core CPU with each processing 16 pixels for a 2 gigahertz clock speed on the CPU, and let's say running at 2 operations per cycle. That's nearly 1 teraops per second, right? And what we've seen is that modern servers have increased core counts far beyond 16. And each one of these cores have this little AVX2 engine in it. So we can spread the load of PCoIP Ultra across the system much more evenly. So what about on the client side? Here's a quick slide on client compatibility. So one of the things we need to know about PCoIP is on both the host side, which is generally a powerful workstation or a virtual workstation on the server, and the client side, so a low power device like a zero client, thin client, or a user's home laptop or desktop. Both sides must support AVX2 in order to take advantage of PCoIP Ultra. AVX2 is generally supported on the workstation or server side, at least modern workstations and modern servers. And AVX2 can be found in most modern home laptops or desktops. But we'll talk a little bit more about the challenge with AVX2 with the zero client and thin clients. So on the top row there, we have the PCoIP zero clients. So today we have our zero client is called the Teradici zero client. And it's capable of decoding PCoIP Gen 1 with great performance as it has fixed function silicon built in. But the fixed function silicon also limits the ability to add new functionality to it. And thus the zero client of today is not capable of doing PCoIP Ultra, unfortunately. In the middle there, thin clients. So today, many thin clients actually don't have support for AVX2. And the reason for that is they're using generally lower power CPUs than what you would find at a home desktop or a home laptop. But we do see exciting new ones coming to the market. For example, IJO, which is also a Tehima partner, they have a new thin client they released called the UD3, and it is capable of PCoIP Ultra as it has a AMD CPU built in that is capable of doing the AVX2 instruction set. The performance on thin clients is good enough for a lot of different use cases, but the performance for PCoIP Ultra is really dependent on the performance of the CPU itself, beyond whether or not it's capable of AVX2. So for the most demanding use cases, such as, again, media entertainment, we recommend using a full client or a fat client. And that leads us to the bottom here, the modern full or fat client, right? It's capable of all the workloads, right? So it's capable of PCoIP Gen 1, PCoIP Ultra, NVENC, so it ticks all the boxes. And actually, to bring the discussion back to NVENC a little bit here, we use the highest quality version of H.264, the video codec, which is known as 444 mode. So there's 3 4s there. There are very few GPUs that's capable of doing hardware accelerated decoding of H.264 in 444 mode. So again, NVENC is encoding, but there's also a decoding aspect. And there's not that many GPUs that can do it at that high quality level. So unfortunately, we do have to decode today using the CPU, which does put a demand on CPU performance. So if you're using the NVENC encoding in the H.264 444 mode, we recommend having a relatively powerful full or fat client. And we do talk a little bit there about sort of the clock speed recommendation there as well. Cool. So let's switch gears for a little bit and look at some CPU and bandwidth performance metrics. So this test was done by our benchmarking team. And the system they've used was the Dell R7910 with a 4-core 8-thread CPU running Windows 10. It was virtualized under ESX 6.7 using an NVIDIA M60 and Grid Driver 8.0, as well as a ASUS, basically it was a mini PC, and that's also running Windows 10. So here's a comparison between PCoIP Gen 1 and PCoIP Ultra. The workload is playing back 1080p video at 60 frames per second. Now you may be thinking, that isn't really performance intensive, right? I mean, my smartphone can do it with no problem. So why are you guys showing this to us? So one of the fundamental behaviors of PCoIP is that we only encode and send change pixels across the network. So the more pixels and the faster the frames change, it leads to a greater utilization of bandwidth and CPU. Whereas in scenarios where you actually may be using a lot of CPU, such as when you hit the render button on a video editing software like Adobe Premiere or 3D rendering software like Blender, what's shown on the screen is actually only a little progress bar, right? So in that case, the PCoIP utilization of the CPU and bandwidth will be low, but the software such as Blender and Premiere may be pegging the CPU and the GPU at 100%. So that's sort of how you determine the bandwidth and CPU usage for PCoIP. Looking at the chart here, we have 4 different configurations of the remote workstation, with PCoIP Gen 1 using anywhere between 45 to 15% of CPU, depending on the number of cores you have. When we switch to PCoIP Ultra, we see a savings of 25 to 35% lower CPU usage, depending on the configuration, with bigger benefits to smaller core count. And as we see a sort of a proliferation of core count to be available in physical workstations and servers, we can see that the higher core count workstations become available to more and more users, and the advantage of PCoIP Ultra really grows. Yeah. Okay, another chart here. It shows the bandwidth usage of PCoIP Ultra. And we show a comparison bandwidth usage of PCoIP Gen 1 versus PCoIP Ultra in the next slide. And what you see here is 3 different quality settings, right? Q70, Q80, and Q90. The quality scaling of PCoIP is from Q10 to Q100, with Q70 to Q90 being considered high quality, and Q100 being considered lossless. From the Q70 to Q90 range, we get into what we call perceptually lossless quality. What that means is that the naked eye is generally not capable of telling the difference between an image that is perceptually lossless and the original image itself, with the image that is perceptually lossless being actually more compressed than the original, thus resulting in bandwidth savings compared to sending just the original image across. PCoIP PCoIP Ultra can be bandwidth intensive at higher resolutions and quality settings, but for your most demanding users, such as users in the M&E industry, the quality difference between PCoIP Ultra and a competing remoting protocol is definitely noticeable, and I think you'll find a trade-off for those demanding users to be worth it. So what about bandwidth efficiency, right, of PCoIP Ultra compared to Gen 1? Well, with the improved protocol, we're actually able to save roughly 25% of the bandwidth compared to PCoIP Gen 1. And I think for certain users that are bandwidth constrained, PCoIP Ultra might be a good option to explore and check. Okay. So finally, let's take a look at NVENC, right? As previously stated, NVENC is a dedicated hardware that is built in that enables accelerated H.264 encoding and is built into most modern NVIDIA GPUs. This enables us to offload certain tasks that were previously done in the CPU, so previous tasks that were done by the AVX2 instruction set, off to the GPU. So what this means is that more of the CPU performance is freed for other tasks. And one use case that I've seen that utilizes this is for CPU-based 3D rendering. So something similar to Blender, where all the cores are being pegged at 99%. In this scenario, if the user wants to do something while the scene is being rendered, such as replying to emails or browse the web, PCoIP Ultra AVX2 performance might be bogged down as there's not enough available CPU resource to perform adequately. However, with the GPU offloading, you'll be able to reduce the demand on the CPU. Thus, it leads to a better user experience in CPU bottleneck scenarios. Okay. So before I continue to the next slide, I just actually want to stop here and actually do a little bit of a demo. I am going to share my desktop. So just a couple caveats here. The demo I'm performing on is we have our own private demo environment to do it. So this is not the Tahima system. So I would envision when we do performance testing on Tahima, the performance should be comparable between the two. And just let me share my desktop here. So, and the other thing is I'm connected at home using Wi-Fi, unfortunately. So, cool. Are you guys able to see my desktop now? I'm gonna assume yes. Okay, perfect. And I just need to copy my password and connect. Yeah, so that's one of the challenges is that we prefer to have to be on a wired network. Unfortunately, the way my house is laid out, it's not really possible to run a wire here, but we can get decent performance here. So I'm just connecting to my desktop here. As you can see here, now I'm on a different looking desktop. And if I do here, I'm gonna drag it over here. Are you guys able to see the video playing?
Yep, that's good.
Okay, excellent. Yeah, so this is just a demo video. It's called Big Buck Bunny. This, there's no real copyright attached to this. So it's able, I'm able to, freely play this on stream here. But as you can see here on the top left, I'm using what we call the high performance client. And in the latest release of the high performance client, we have a statistics overlay. And this shows, things like frame rate, what kind of codec you're using, as well as things like drop frames, which is very important for those media entertainment customers who want, pixel preciseness, right? So as you can see here, I'm using the original PCoIP, so PCoIP Gen 1 here. And the frame rate here, if I just move my mouse away, it's roughly, it can get up to 60, but, it's usually playing back about 30 frames per second. And we're actually really good on drop frames. We're not dropping that many frames. We're dropping, one frame in the past 400 something frames. As you can see here, now it's going up to about 40 or 50 in terms of performance. So it's decent, right? So I'm going to let it play for a couple more seconds here. Again, for user, now we hit up to 60, right? But for users who want to say, I want to hit, as close to 60 as possible constantly, this is not good enough, right? Going from, high 50s to drop down to about 30 and then back to 40. It's not really consistent for those users, right? So what I'm going to close that video, and what I'm going to do next is I'm going to open up GPEdit. And for those of you who are familiar with the Windows administration, this is basically a way for you to change certain settings. And when you have the Cloud Access software installed, which is installed in the Tahima rooms, you're able to change PCoIP session variables, and then I will go into overridable variables. And in here, there is an option to enable PCoIP Ultra CPU optimization. So I'm going to say here now, by default, it's not configured. So I'm going to hit enable here and hit apply. And I will need to disconnect. So I'm going to disconnect and go back. This is my regular desktop. I'm going to connect back to the same system. Hit login. And here you go, right? It says PCoIP Ultra, CPU optimization. And since it's not doing anything, and there, there's a little bit of a bug where you go in for the first time, it may drop some frames. But as again, if I open up the same video again, Big Buck Bunny. And if you look at the frame rates, it's much more consistently 60 frames per second than previous. Yeah, I don't think it would drop below, 55 frames per second. But yeah, for those users who say, hey, I need to have a consistent, oh, actually just did drop, but at least it's much more consistent than what we can get using compared to regular PCoIP as well. And again, very important for the media entertainment or any users who are very demanding in the performance. You can see that we're not dropping any frames using the high performance client. Yeah, and this is playing back at the 1080p, 60 frames per second, if you're wondering. So yeah, so I'm gonna pause here and go back. I'm gonna disconnect and go back to the slides there. Just give me 1 second as I share my presentation. Okay, so this was the last slide we were on. So moving on to the next slide. Here are some of our customer stories for customers who are using our product. One case study that I want to give a very quick shout out to is DNAG. So on the top right there. If you ever watched a Star Wars or an Avenger film, you have undoubtedly seen the work of DNAG. They're a global VFX company that does a lot of work for studios like Disney or Marvel. And they were one of the earliest adopter of Teradici Cloud Access software and virtual workstations, and an early innovator of technology in general. So yeah, if you want to learn more about how DNAG is using Teradici to produce VFX for Avenger films or Star Wars films, I would recommend checking out the case study. And finally, here we go. So if you want to learn more about Teradici and PCoIP Ultra, you can go to those links. And if you ever have any questions about PCoIP, you can definitely feel free to reach out to me there. And that's the end of my slides, guys.
Awesome. Thank you so much, Jack. I don't see any questions in the chat or the Q&A at the moment. Yeah. But if anyone does have any questions, they can put it in the DVD Slack, or you can email me or Jack directly.
So I do have a question for Dean, right? So as I've stated previously, Teradici product and cloud access software and PCoIP Ultra is available in many different cloud platforms. So Dean, can you tell us, what's Teradici doing with Tehima that differentiates their offering versus, the other variety of platforms that's available out there?
Yeah, thanks, Jack. So yeah, just want to talk a little bit about what we've been doing, professional services and Tehima. And so, as Jack's really kind of clearly described there with, PCoIP is the underlying protocol that's being used actually for the Tehima remote desktops and Tehima rooms. So it is the protocol that makes for the remote desktops. Our professional services team has been working really closely with the Tehima engineering teams for some time now. And one of the developments we've had has been a single-click software client that connects to a user's remote desktops. So once a user authenticates to the Tehima portal, they'll simply click connect, and then within seconds, they're connected to the remote desktop. So we've been, again, working really closely with the Tehima team to get that in place. Number of features that are there are things such as branding is possible, scaled desktops, and PCoIP Ultra, as Jack's mentioned. Now, this works across multiple platforms as well: iGel, Windows, Mac, and Linux. And a number of new features we have in the pipeline will be coming down the road. And so there'll be more enhancements to come in the future. So I just want to say a quick word about, again, our professional services team and Tehima partnering together and teaming to produce, again, that single-click client. Thanks.
Yeah, thank you so much, Dean. Yeah, and just what I want to add is that Teradici and Tehima has been working very closely together in, just not just providing what's available for existing partners to integrate with, but we have seen Tehima add a lot of value-added software on top. Sorry, just hold on. Sorry, I just have a little bit of a code here. So what they have done, obviously, besides just the traditional values of Tehima, of their rooms, and their ability to securely, bring your existing on-premise information into a Tehima room, in the quick demo that I've seen, glimpses of a demo I've seen from the folks at Tehima, they have integrated bandwidth usage, CPU usage, user session usage, and there's a whole host of features that you would not be able to get on other platforms, or platforms, if you decided to, hey, I just want to buy directly from Teradici and get the same thing as Tehima, you won't be able to, because Tehima have done a lot of extra work and has put in a lot of value adds that you only get by going to the Tehima platform. So I think that's one of the biggest differentiator, right? A lot of customers may be deciding between, hey, do I want to do my own deployments of Teradici, or do I want to use Tehima, or do I want to use another product? I just want to say what Tehima have been doing has been a tremendous amount of value add. So in a former life, I used to be a IT administrator, and just looking at what they've added, I would say, yeah, you would sell me right away over a vanilla Teradici or a cloud access deployment, because of all these additional values that Tehima bring to the platform. And yeah, that's
awesome.
Just a quick 2 cents there.
Awesome. Thank you so much. Do you guys have any last words before we wrap it all up?
Nope.
No? Okay,
Thank
then
you.
I think that ends the session. Thank you so much, Jack and Dean, and the rest of the team for joining us, and all of the attendees. And with that concludes the vendor session. We hope to see you all tomorrow.
Awesome. Thank you, guys.
Bye.